Hello, my name is Miles Schofield, and welcome to another episode of the AOPEN Tech Playbook. Today we're talking about the Great Resignation, aka the fact that millions and millions of people left the U.S. job market in the last few years. And so what happens when a lot of people leave the job market? Well, labor gets more expensive, more competitive, and companies got to figure out a way to sort of avoid those extra costs. Otherwise you get, as you know, inflation, right? So what's the number one way that they sort of combat the labor costs? You know, this is a tech show. You know what we're talking about. We're talking about automation and, of course, robots, right? And the robots are always going to be stealing your jobs. So in this video, we're only talking about the U.S. job market and specifically labor in the U.S. job market. Lots of people left the job market for a lot of different reasons in a lot of different countries. But, of course, countries have different population, ages, size of the workforce. Specifically, we're just talking about U.S. today. The second thing, which is how corporations are always working towards to replace people, right? It's always their OPEX is always expensive. You always have to find a way to make the labor cheaper in what you're doing. And of course, the way that automation is sort of implemented today and how it may be implemented in the future. So let's talk about how bad the job stall was. So when we look at, it doesn't look that bad from this graph. You know, it's only a few points, right? But these sort of shifts do make a major impact, are sort of a cause for alarm. You can see that if that trend had continued in 2020, had not happened, then we'd be at a few more million people in the job market right now, which is a few points. This sort of change is impactful for not only this reason, a lot of people left in 2020, but for the second reason too, which is of course something that been people talking about and predicting the doom in the United States forever, which is how not only are you going to have 2020 causing a lot of people to shift out of the workforce, but you're going to have once the baby boomers hit that retirement age, then you can see the baby boomers are that upper sort of peak, and once that peak goes, the growth of the workers in the United States are going to stagnate once again, right? So labor is a problem that I don't see is going to go away in the United States for at least another 10 years, right? There's still going to be a squeeze. I'm sure you've heard about how other countries have tried to incentivize low-cost workers and encourage people to have children to grow the workforce in the future. But as far as I know, United States have not offered any incentives like that yet. So you can see that it's continued to trail pretty much down in the United States ever since about 30 years ago, right, where that second peak is, right? So what this all leads to is, of course, U.S. labor being very expensive. Now, this is back in 2017, this graph. I chose it because it's about robots, right? And U.S. labor is expensive even back in 2017. It's even more now. You can see by the yellow bar above USA, it's slightly to the left of center, about $40. And this chart just shows that, the automation and robots already do have sort of an effect on different economies in different countries. And you can see that all these countries with, relatively high labor, they're already trying to implement these types of technologies. And you have to remember that if you look at all these names, these are all the largest, richest countries in the world, right? That's why they're so focused, is because the countries with the most expensive labor are the ones most focused on automation because they have the largest reason to do so, right? The other interesting thing to think about in terms of what jobs you want to automate in terms of the technology out there is, why would you want to automate a basic labor job like manufacturing over some of the articles you see that say it's going to be lawyers and programmers and things like that. And the main reason is currently the way that the tech is implemented is that it needs to be extremely repetitive, right? And the challenging thing about programming is not the repetitive aspect of it, which is when you get paid a lot as a programmer when you're doing something new and adaptive, and you have to solve a lot of problems, which AI just needs something extremely repetitive to do. So it's more likely that instead of replacing programmers and lawyers, AI will be doing much more of a testing and improve the performance of those type of roles instead of actually replacing them. So let's talk about robots in general. So robots, and when I talk about robots, I'm not necessarily just talking about robots, I'm talking about AI, right? When people think about their job being taken over. They don't want to think about some piece of code running on a server in the middle of nowhere. They want to sort of, it's better to imagine some, thing with a face, right? That's doing a physical task that they're sort of familiar with. But of course, for any one of these tasks, you don't need a humanoid type robot, right? There's lots of different types of ways to move things, and you have vehicle type robots and overhead robots, more crane type robots and things like that. But in terms of robots, what we're really talking about is machine learning, big data, and we're talking about AI, right? The three things you need to actually do a task and automate it in an intelligent way, right? So this whole idea of the labor getting more expensive in the United States, it's been an idea in the United States for at least 10 years, right? So, and it started because there were some key advancements in AI technology back in 2010, 2011, when Watson beat everyone in Jeopardy, right? Before that, when you had Deep Blue beat Kasparov in chess, that was something that seemed too niche, right? It was like, okay, it can do chess, but only because it knows this exact precise thing, and chess is a very data-driven sort of activity. But Jeopardy seemed like much more general knowledge case, and it used a lot more complicated tech to use that. So ever since then, some key technological advancements have happened, and that's just made it super important, and it's been a key factor ever since then. I've heard anecdotal evidence of just if you just have it on your resume, any experience, it was, one of the anecdotes I heard was, that Stanford couldn't keep any machine learning grad student ever. Like, no one completed the program because companies would just steal them. And I'm pretty sure that's probably still happening today, given how important this type of technology is to the future of the way jobs work in the United States. The second thing I wanted to talk about in terms of importance, the way that is portrayed in the media, is, of course, you see these articles. Technology has always been the bugaboo that's going to steal your job, and it usually doesn't hold that much water, because as more things are automated, there's always new types of careers that open up. So when we talk about how this tech is implemented, right, we're trying to automate a system, and let's just talk about a physical system right now. Maybe we're flipping burgers, right? So the main thing is, in order to flip burgers, we need to have timing. We got to have some mechanical aspect. We have maybe we have sensors around to see if the burger's cooked, So where is that processing power being done, right? It's not like we can just tape a computer to the side of the robot and knows what's going on. And so this is the big challenge when we're implementing AI, especially when it's, or robotic systems, especially when humans are around, right? Where do we put the computer? Where do we put the processing power? And how expensive is it? And how much space does it take up? And all this sort of stuff. And so this conversation is really about the way that modern computing power is thought of through this concept of cloud, right? So if you're not familiar with what the word cloud means, it just means non-centralized computing resources. So hard drive space and computing space, right? It's somewhere over the internet, right? Sometimes in a server farm, sometimes in multiple server farms. And there's lots of different ideas about how the cloud works and different types of cloud: local, distributed, private, public, blah, 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 blah. They all do different things. But the main point is that you're trying to put those resources in a place that makes the most sense for your particular application, right? And so when it comes to AI systems, especially mechanical ones, the biggest challenge is that the resources need to be close, because any sort of lag can cause the mechanical system to perhaps make the wrong decision, right? Best way to think about this is if you tried to run an automated vehicle completely over the cloud, right? It's sending all that video data over the internet, waiting for the cloud to sort of get back and tell them if there's a pedestrian in the way. And if you lose internet for a few seconds, maybe you sort of gotten in an accident, right? So any sort of lag or time sensitive thing is not great. But that's why, if you watch the last video, a lot of where this computing power is dependent on how well these sort of wireless and high-speed data technologies develop in the future as well. So but the bottom line is that the old system, right, before cloud, all the computing power, everything you did needed to be what's called on-prem or on-premises, right? Which means that if you had a Burger King franchise, absolutely everything, every single system was in a server rack in the back, right? And that's the main thing that cloud really solved, is that you can have these independent systems with low on-site computing, and then you can relegate a lot of the hard drive and the storage and the processing to other servers that are managed by professionals, instead of having to take care of those resources at each and every single site, which is extremely expensive. So when we talk about when you're forced to put hardware on site for like a robot or a time-sensitive thing, you're going to need some type of computer, right? And so there's a lot of different types of computers people use. Mini PCs like AOPEN makes. They can be, if you're doing something AI that actually needs to do some sort of complex visual processing, they make special computers that can hold like 4 to 6 graphics cards. There's a lot of different types of isolated edge or IoT computing you can do for these particular types of application. And once again, how powerful these devices end up being will sort of all be based off of the cost of maintenance on site, how smart the system is, how smart the system needs to be, and how much of that processing can you actually push to the cloud in a safe way, and of course, how much does the cloud cost? And, if the cloud ends up costing nothing, maybe a little bit of lag's okay, right? So all these questions are, of course, play out constantly in every single decision when one of these systems gets implemented. So let's talk about how practically these things go. I've mostly been talking about robots because it's a little bit more interesting to talk about how something physical is implemented instead of something that's strictly data-driven, like just the way that security systems and things like that are being implemented. So when we talk about the way that, for instance, these mechanical arms are being implemented, the main thing to point out is that they're being implemented in very condensed fashion. And what I mean by that is, they have their own controller in there, they have their own brain in there, they're very encapsulated, and they don't interact with a lot of other things, right? You're bringing a piece of technology into this cafe that sort of is isolated and keeps separate from everything. Because that's one of the biggest challenges, is that when you're trying to get one of these systems to work with other systems, for instance, human systems, right? A lot of these environments are designed to have humans in them. And so if you just say, hey, let's slap an arm in there, well, how are people going to move around the arm? What happens if you got to store something near the arm, or in all these sort of issues? It's very difficult to design for two completely different types of workers and effectively use cases, right? Even though they're doing the same thing, right? So that's the biggest challenge when you're trying to implement these mechanical things. And for the most part, most of the mechanical robotic things end up looking like kiosks, right? Because it's dangerous. You don't want to have to pay to put sensors all over your robot, make sure it doesn't, whack one of your other employees who's doing their job as well too. So they end up effectively being sort of like kiosk, like more vending type things to solve this problem, instead of what you see on the bottom, which is sort of like workers nearby. That's also why when you look at videos of Amazon warehouses, packaging warehouses, that robots always have very explicit lanes, right? So no one gets run over and things like that. The humans and the machines need to be separated because it's expensive to have robots that move near humans, right? Because they need all those extra sensors to make sure they don't hit anybody hard, right? So the second way is, of course, full integrated. If you can get humans out of the equation and alleviate all those problems, right? Robots still have problems, Amazon would get rid of the people if they could, but robots are just bad at certain things, like handling oddly shaped objects, handling delicate objects, right? There's the actuating the grip and the touch is just not cheap, easy to achieve, and dynamic enough yet to really replace that idea of going around and picking and choosing and handling a lot of different unique small items. In the future, sure. But so aside from that, when we do a full integration, we can just design everything around the robot's capabilities. And so I'd really encourage you to take a look at this Tom Scott video where he reviews or talks about the technology behind a completely automated grocery store. So this picture you see below is a grocery store as it would look, where you would have no human there. So it's not like this is the ceiling or the floor. This is just the entire grocery store. So the food's not laid out. Every single SKU is each in one of those little bins. And when you order your groceries online, these robots sort of know your order, and they go to the SKU and they pick it up and they put it in a basket, and then your basket goes and then you pick it up outside. So no one's actually allowed in this facility, right? Because trying to get these little, car-like robots to navigate around people in a crowded supermarket and deal with shelves and the way that regular supermarkets run is a completely different problem to solve. And so when you can design something top-down for automation, you can come up with a much more elegant solution, as you see here, that removes a lot of those typical issues. So the way you should think about it is that you can have a human grocery store, and then you can have a fully automated grocery store, and it actually turns out that it may be just way more difficult to actually have a human and automated grocery store at the same time due to some of those challenges that I talked about. So I hope that gives you an idea about some of the challenges in which way these type of systems are implemented. I hope you found this video interesting. So until next time, my name is Miles Schofield. Have a great day.